To determine the voltamps on plug molds, particularly a 6-foot strip with 6 outlets, it's crucial to understand the relevant electrical codes and guidelines. The National Electrical Code, or NEC, provides the framework for safe electrical installations. When dealing with multi-outlet assemblies like plug molds, you can't simply assume each outlet will draw its maximum rated current simultaneously. Several factors influence the actual load calculation. Firstly, consider the specific application. Are these outlets intended for general use, or will they power specific, known loads? If the use is general, the NEC has specific rules to follow. For dwelling units, which include houses, apartments, and similar living spaces, the NEC requires a minimum load calculation for general-purpose receptacles. This calculation ensures that the electrical system can handle the anticipated load from various devices plugged into these outlets. However, plug molds are often used in commercial or industrial settings, and the rules may differ slightly. Secondly, examine the rating of the plug mold itself. Most plug molds have a maximum amperage rating printed on them. This rating indicates the total amount of current the entire strip can handle safely. It's essential not to exceed this rating, as it can lead to overheating, damage to the plug molds, or even a fire hazard. The rating is often expressed in amps, and you can convert it to voltamps by multiplying the amps by the voltage of the circuit. For example, if the plug mold is rated for 15 amps on a 120 volt circuit, the maximum volt amps would be 15 amps times 120 volts, which equals 1800 volt amps. Thirdly, consider the connected load. If you know the specific devices that will be plugged into the plug mold, you can calculate the total voltamps by summing the voltamps of each device. The voltamps of a device is often listed on its nameplate, which is a small label typically found on the back or bottom of the device. If the nameplate only lists the wattage, you can convert it to volt amps using the following formula: volt amps equals watts divided by the power factor. The power factor is a measure of how efficiently the device uses electricity. For resistive loads, like incandescent light bulbs or heaters, the power factor is close to 1.0, so the voltamps is approximately equal to the wattage. For inductive loads, like motors or transformers, the power factor is typically less than 1.0, so the voltamps will be higher than the wattage. If the power factor is not listed on the nameplate, you can assume a power factor of 0.8 for inductive loads. Fourthly, apply demand factors if appropriate. In some cases, you may be able to apply demand factors to reduce a calculated load. A demand factor is a percentage that represents the likelihood that all the connected devices will be operating at their maximum load simultaneously. For example, if you have a plug mold with 6 outlets, and you know that only 3 of the outlets will be used at any given time, you could apply a demand factor of 50% to the calculated load. However, demand factors are typically only allowed for specific types of loads and under specific circumstances, as outlined in the NEC. You should consult the NEC or a qualified electrician to determine if demand factors are appropriate for your application. Now, let's consider how to apply these principles to your specific scenario: a 6-foot strip with 6 outlets. Firstly, determine the rating of the plug mold. Check the label on the plug mold to find its maximum amperage rating. Let's assume the plug mold is rated for 15 amps at 120 volts, which is a common rating for general-purpose plug molds. This means the maximum voltamps for the entire strip is 1800 volt amps. Secondly, consider the potential connected load. If you don't know the specific devices that will be plugged into the plug mold, you'll need to make some assumptions. A reasonable assumption for general-purpose outlets is to assume a load of 180 volt amps per outlet. This is based on the NEC requirement for general-purpose receptacles in dwelling units, which requires a minimum load of 180 volt amps per outlet. Thirdly, calculate the total voltamps. If you assume 180 volt amps per outlet, the total voltamps for the 6-outlet plug mold would be 6 outlets times 180 volt amps per outlet, which equals 1080 volt amps. This is well below the maximum rating of the plug mold, so it should be safe to use. However, it's important to remember that this is just an estimate. If you plan to plug in devices that draw more than 180 volt amps each, you'll need to adjust your calculations accordingly. For example, if you plan to plug in a space heater that draws 1500 volt amps, you'll need to ensure that the total load in the plug mold does not exceed its maximum rating of 1800 volt amps. In that case, you would only have 300 volt amps available for the other 5 outlets. Fourthly, consider the circuit breaker. The circuit breaker that protects the circuit supplying the plug mold should be sized appropriately for the load. A 15 amp circuit breaker is typically used for general purpose circuits in dwelling units. If the plug mold is rated for 15 amps, a 15 amp circuit breaker would be appropriate. However, if the plug mold is rated for more than 15 amps, you'll need to use a larger circuit breaker. It's important to note that you should never replace a circuit breaker with a larger one without consulting a qualified electrician. Using an oversized circuit breaker can create a fire hazard. Fifthly, ensure proper grounding. Proper grounding is essential for electrical safety. The plug mold should be properly grounded to prevent electric shock. This means that the grounding wire in the plug mold should be connected to the grounding wire in the electrical outlet. If the outlet is not properly grounded, you should contact a qualified electrician to have it corrected. Improper grounding can create a serious safety hazard. Sixthly, avoid overloading the circuit. It's important to avoid overloading the circuit that supplies the plug mold. Overloading a circuit can cause the circuit breaker to trip, which can be inconvenient. It can also create a fire hazard. To avoid overloading the circuit, you should be aware of the total load on the circuit and avoid plugging in too many devices at the same time. You can determine the total load on the circuit by adding up the volt amps of all the devices plugged into the circuit. If the total load exceeds the rating of the circuit breaker, you should unplug some of the devices. Seventhly, inspect the plug mold regularly. You should inspect the plug mold regularly for any signs of damage. Look for cracks, frayed wires, or loose connections. If you find any damage, you should replace the plug mold immediately. Damaged plug molds can create a fire hazard. Eighthly, use surge protectors. Surge protectors can help protect your electronic devices from damage caused by power surges. Power surges can occur when there is a sudden increase in voltage on the electrical circuit. This can be caused by lightning strikes, power outages, or other electrical problems. Surge protectors work by diverting the excess voltage away from your electronic devices, which can help prevent them from being damaged. Ninthly, follow manufacturer's instructions. Always follow the manufacturer's instructions when using plug molds. The manufacturer's instructions will provide important information about how to use the plug mold safely and effectively. Failure to follow the manufacturer's instructions can void the warranty and create a safety hazard. Tenthly, consult a qualified electrician. If you have any questions or concerns about electrical safety, you should consult a qualified electrician. A qualified electrician can help you determine the appropriate electrical load for your plug molds and ensure that your electrical system is safe and compliant with the NEC. Electrical work can be dangerous, so it's always best to leave it to the professionals. By following these guidelines, you can safely and effectively calculate the volt amps on plug molds and ensure that your electrical system is safe and compliant. Remember to always prioritize safety and consult a qualified electrician if you have any questions or concerns. In summary, to calculate volt amps for plug molds, you should firstly determine the rating of the plug mold itself. Secondly, consider the connected load by looking at the nameplates of the devices plugged in. Thirdly, apply demand factors where applicable based on the NEC guidelines. Fourthly, ensure the circuit breaker is appropriately sized for the total load. Fifthly, verify proper grounding to prevent electrical shocks. Sixthly, avoid overloading the circuit to prevent trips and hazards. Seventhly, regularly inspect the plug mold for any signs of damage. Eighthly, consider using surge protectors to protect devices from voltage spikes. Ninthly, adhere strictly to the manufacturer's instructions for safe usage. And tenthly, consult a qualified electrician for any uncertainties or complex scenarios to ensure compliance and safety. Remember, safety is paramount when dealing with electrical systems, so do not hesitate to seek professional advice.